Hi, this is Mr. Sikander. In this video lecture, we will learn the various use cases of static keywords in C. Static keyword can be applied for variables, that is the local variables. It can also be applied for global variables, and it can also be applied for functions. Please don't confuse this with static data members and static member functions in C++ or in Java. They serve a different purpose. We will only be looking into the use case of static in C. So the first thing we'd like to start off with basically is the static keyword applied for local variables. So I'll just try to write a program, which is a test static.c. Let me have the main function first, and I'd like to also have one more function out here. You can name it anything. In this, I'd like to create two variables. Now, this particular variable, what I've created out here, it is basically called as a local variable because it is inside the block. Okay, this is basically called as local variable. Okay, now local variables have a scope limited to the function. Scope in the sense the area where exactly it is accessible. It is accessible only within this function. Right? Now this particular variable has automatic allocation, meaning it will be created or memory gets allocated for this variable when you enter into the function, and memory will be destroyed once you come out of the function. The lifetime is begin to end of function. Good. I have initialized the value to 0, but in case if I had not initialized the value, so in that particular case, we call it as a default value. The default value of this will be garbage. If you do not initialize an automatic variable, the default value will be garbage. And the memory segment where this particular variable will get the memory is basically the stack segment. Fine. Okay. Now, let us create one more variable. Only thing is, we'll just try to use this keyword called a static before this. Now, since this has been created inside the block, it is still called as local variable. Whereas, since we have used this keyword static, it does not have automatic allocation. It has static allocation, meaning the variable gets created at the beginning of program to end of program. Please remember here. So automatic variables begin to end of the function, whereas static variables beginning of program till the end of the program. Right? Now, the default value, that is the value if you do not initialize it, for this static variables will be 0. Same way, memory segment where the static variable gets memory is data segment. Okay, if it is not initialized, it will be into BSS segment, or initialized to 0 will also be BSS. Initialized something else, it will be a non-BSS segment. Fine. Right. Now, the key difference out here is, since x is a local variable which gets destroyed at the end of the function, it will lose its value. So next time you enter in the function, it will restart from the beginning. Whereas the static variable, since it does not get destroyed once you come out of the function, it will retain the value, okay, of this variable. And the second time you enter the function, it will continue from the point where it had stopped. To demonstrate this particular thing, I'm just trying to increment the value. Let me try to increment this value of x by 5. And the same way, y also I'd like to increment this by 5. After this, I'd like to print the value of x and y. I'll say this is my x value. And same way, I'd like to print the value of y, which is the variable what I have. Fine, that's it. I'd like to call this a more meaningful name for the function will be better. The first time you call, you won't see any difference between the value of x and y. Let's see, gcc test_static.c. You can just observe, you don't see any difference. Now, the key difference, what you can observe is when you call the function for the second time. When you call the function for the second time, Automatic variable gets created again and starts from 0. 0 plus 5 is 5. Whereas static variables, what happens is it will be continuing from the point where it has stopped. So second time this value is 10 rather than being 5. Okay. If you want to understand this in more detail, we can just try to do debugging. I'm trying to compile with -g. After that, I'd like to start a debugging, gdb space a.out, right? Now we can see this message. If you don't want to see this particular message, okay, while launching the program, we can use the flag called as -silent. I'd like to clear this. I'd like to set the breakpoint at main, start the execution, and then use a step command. I'd like to get into the function, right? Now I'd like to list this program. I can, so that I can understand what is the code, what I have it in each of the line. Okay, right. After this, I'd like to execute the next step. So here you can just observe, after executing line number 4, it executed line number 5. Okay, right. After that, it did not execute line number 9. It directly jumped to line number 14. It jumped to line number 14. Why? Because the static variable is initialized at the time of loading, not the first time you enter the function, right? But any other operation like updation, that will be executed in every call. So after that, we did execute and then print the value of x, print the value of y. So we could see the value of x and y is fine, 5 and 5. Then after this, you'll be back at the main. Second time you call, you again enter in, right? Then x will be again set to 0. But remember, if you see, I did not execute this statement out here. Okay, if you just wanted to see what is the value of x, remember, I'm yet to execute this line. So this one has the value 0, print to y, it has 5, right? Now, after executing this line, x value will be changed from 0 to 5. And after executing this particular line, y value will be changed from 5 to 10. Clear? And that is what you could see out here. Okay. Now, this is about the local static variables where the value of the variable is not destroyed, okay, at the end of the function. It will be retained and will continue from the point where we had stopped. That's about the local static variable, right? Now, we would like to look into global static variable. So let me just try to work with test global static.c. Okay. See, any variable which is declared outside all the functions, they're basically called as global variables. I'll just try to write global equal to some value. Okay, this particular variable is accessible across all the functions. Fine. Now, I can also apply static for this global variable, right? Okay, I'll just say yes underscore global. I can set any value. Fine. Okay. Now, this can also be accessed by all the functions which is present in this particular file. Okay. If you're basically doing the programs which are related to a single file, you may not see any difference between this variable and this variable. The difference of this you can only observe when you basically work with multiple files. Okay. Like first, let me try to demonstrate that I do have a function. That function can be before or after the main. But if it is after the main, we need to basically have the declaration. Here, I'm trying to print the variable global equal to %d. And then I'd like to also print the static global. Okay. After that, I'd like to call this function. I'd like to write this 2 lines in this function. Okay, right. So you can observe that this particular variables are accessible in both the functions. Let me try to compile this. Test underscore global static. It is accessible in both. Yes, you can modify in one of the file, one of the function, it will be reflected. But if you wanted to see the difference between this, first, let me show you the symbol table. I'm trying to write nm command, which is basically used to see the symbol table entries in a .to file. I could see that there is global, which is into data segment, where you can see D as uppercase, and yes underscore global, which is under, again, lowercase d segment. Both are in data segment, but this basically says that it has external linkage. This basically says that it has internal linkage. So what do you mean by external linkage? That particular variable can be referred from the other file, whereas internal linkage in the sense this variable cannot be referred from the other file. How do I refer to a one global variable, okay, present in one file in the other file with the help of extern? So let me try to create one more file. I say file2.c. Here, let me try to write function2 here. If you basically wanted to refer to this global variable, this is in function2. Either you can write this way, or if you want, you can basically explicitly write the function name and the file name by using this macro, the file name as a function name, and then I'd like to write, right? I'd like to just say the function name and the file name. So to mention the file name, I'll just try to use this predefined macro, and then this one for function name, and then the variable here. And the same way I'd like to do it for the other one. Okay. Right. Remember, the variable is present in the other file. And if I just only write this particular code, right, and with an hash include, you will face an error that global is undeclared, s underscore global is undeclared. You will basically face an error. Okay. Because during the compilation time, the compiler needs to have a look at the declaration, and during the linking time, it can find the definition. Okay. So first, let me just try to compile this file. I'll say gcc -c file2.c. You can just see I'm facing an error called as global undeclared, and same way yes underscore global undeclared. Fine. Now, to overcome this problem, I need to use extern. Extern in global. I'll say extern in yes underscore global. Okay. This is just to say that this is only my declaration. Don't define it. The actual definition, you should be able to get it during the linking phase. Fine. Okay. Now let me save this. See here. Previously, I used to get error for both global as well as s underscore global. Now, I'd like to compile this. No errors during compilation. But let me try to link this file. Test global static.c, or we can use a .o file, it's already compiled. Then file2.c. Observe there is no compilation error. There is a linker error because yes underscore global, which is present in the main file, this particular file. Okay, this is not accessible in other file, right? Let me just show you. This one can be accessed from the other file with the help of extern, but this one is not visible from other files. Okay, even by using extern, you cannot access it. Fine. Whenever you wanted to limit the scope of a global variable to that particular file and should not be accessible from the other files, we can take the help of static. Fine. Let me just go back to file2.c, and here I'd like to comment this because I cannot access this. Okay. Compiling both, and you can just see I'm able to access another file. Okay. See, you might be wondering that I have used extern, but remember, it's basically when you basically try to access it, that is the time it tries to refer to that. Fine. Okay. On the same lines, we can also have a function which can be declared as static. I had written this function too, and I have I haven't called this. Sorry, I did not call this from the other file. Let me try to call this from the other file out here. Function I was able to call, but function 2 I did not call. And you want to write the same thing like file name and the function name here? Yes, you can try to write file name, function name. Same thing, I can also apply it here. Would like to have these 2 lines here too. Okay, yeah, we're calling the function 2. We need to also have a declaration of function 2 here. Compile both the files together, and you can just observe this is a file where in the main it has 5, okay, both the variables, and we basically called the other function in the same file. Okay, the function name is func, and later on we went to file 2 where the function name was fun2, and then the variable is accessible. You can modify that and it will be accessible here. So I hope this concept of global variables made as static is clear. Now the next thing I'd like to demonstrate is about static function. Here, I'd like to make a function. Let me just try to write a simple helper function. Okay, and I'll just try to write, this is my helper function. It could be any function name. Okay, now this particular function, I'll try to call it from this place. Right? I'm just trying to call this here. Okay, this is perfectly possible, no problems. Okay, and by default, every function is global, meaning the way I was able to call this function, I will be possible for me to call this function also. But now I'd like to apply this as static. When I make it as static, okay, now what happens is this particular function can be called by other functions of the same file, but not from other files. This particular thing is perfectly valid because this function is being called by other functions of the same file. No issues. Later on, I'll try to call this helper function from the other file. First, let me just show you out here. Compile it, execute it, perfectly fine. Okay. Now, I'd like to go to this. And from here, I'd like to call this. Which one? The helper function. You can try mentioning the static here, not mentioning the static here, right? You can try calling this from main. Okay. First, let me just show you compilation gcc-c test static global. Right? It's saying that helper used but never defined, because since you have mentioned static, it is trying to look out for this function definition within the same file. It is not present. Okay. The same way, if I try to write gcc-c function2.c or file2.c, no problems. When I try to link both files, you can see there is a linker error telling that undefined reference to helper. It says undefined reference to helper. Why is this? Because that particular function is made as static. If I make it as static, it cannot be called or referred from file. See, I've removed static here. If you remove the static, only in the declaration I've removed it, not in the definition. You can just have a look at this cat file2.c. This is still static here. If I try to compile this, you can still see I'm facing the same error because this function is local to this file. It cannot be called from the other files. Now, this could be helpful in case if you want to write any function which is to be limited, where the accessibility of this particular function should be limited in such a way that only the other functions of the same file can be called, but it should not be visible from across the files. Okay, so these are the things what we basically have with regards to static. So let me just quickly summarize this. We studied about local static variables, where we learned that the variable will not be destroyed once you reach the end of the function. It will continue from the point where it stopped in the next call. Global static variables will have internal linkage, meaning it cannot be accessed from the other file. The same way, the static function cannot be called from other file. I hope the concepts are clear. Thank you.